2007, Paper 2, Question 1b, Part 1. X squared plus y squared minus 4x minus 6y plus 5 equals 0, and x squared plus y squared minus 6x minus 8y plus 23 equals 0 are two circles. Prove that the circles touch internally. Here's the centre of the big circle, here's the centre of the little circle, here's the point of contact. The distance between the centres plus the little radius will add up to the big radius if they touch internally. So we have 5 pieces of information to collect. The centre of the big circle, the centre of the little circle, the small radius, the big radius, and the distance between the two centres. We wish to show that the big radius take away the small radius equals the distance between the centres. Here's the first circle, x squared plus y squared minus 4x minus 6y plus 5 equals 0. So g equals minus 2, f equals minus 3, c equals 5. And since the centre is minus g minus f, that gives us a centre of 2, 3 for that circle. Its radius is given by the square root of g squared plus f squared minus c. That's on page 19 of the tables. Substituting, minus 2 in bracket squared plus minus 3 in bracket squared minus 5 gives us 4 plus 9 minus 5, or square root of 8, which breaks down to 2 root 2. The second circle, x squared plus y squared minus 6x minus 8y plus 23 equals 0, gives a value for g of minus 3, for f of minus 4, and for c 23. So its centre minus g minus f is 3, 4. Its radius is given by the square root of g squared plus f squared minus c, or the square root of minus 3 in bracket squared plus minus 4 in bracket squared minus 23, which is 9 plus 16 minus 23, or the square root of 2. And we have the two centres, 2, 3 and 3, 4. Let's find the distance d between these two centres. So we've got this x1, y1, x2, y2. The distance formula, square root of x2 minus x1 in bracket squared plus y2 minus y1 in bracket squared gives us the square root of 3 minus 2 in bracket squared plus 4 minus 3 in bracket squared. That's 1 squared plus 1 squared under a square root sign. Square root of 1 plus 1 is root 2. So the big radius is 2 root 2, the little radius is root 2, and the distance between the centres is root 2. In other words, the distance between the centres is equal to the big radius minus the little radius, and the two circles touch internally.